previous classes, we have covered all the basics that we need to understand LCM and HCF very easily. Right? So what did we study? We studied what factors are, what multiples are, how do we find factors, how do we find multiples, right? And then we saw how the definition of factors lead to the understanding of prime and composite numbers, right? Subsequently, we saw the difference between factors and prime factors, right? And how do we find each of them separately using different method. So if we are just interested in finding the factor of a number, we use the conventional approach. That is, we start to find factor pairs and then use the factor pairs to find the factors of that number. Whereas if we are interested to find the prime factors, only the prime factors of that number, we do prime factorization. To do prime factorization, we use factor trees. Okay. So if you have difficulties in understanding any of these topics, just go back to the video and then you can come back to this topic again once you are thorough with those concepts, because they are going to be very helpful in understanding LCM and HCF. Right? LCM basically stands for least common multiple, also known as lowest common multiple. We already know what multiples are, right? We'll study what common multiples means, and then eventually that will lead to the understanding of least common multiple or lowest common multiple. For HCF, it stands for highest common factor. Again, we have studied what factors means. Now we'll look into what does common factor mean, right? Eventually that would lead to the understanding of highest common factor, right? So we know factors, we'll study common factors and then we'll see what highest common factor means. Similarly, we know multiple, we'll study common multiples and then finally we'll see what least common multiple means. So in this class, we'll be using the listing method to find the least common multiple and the highest common factor of two numbers, right? So in this class, we'll be limited to two numbers only. In higher classes, we can use other methods to find the least common multiple of two or more numbers as well, right? So remember, when we are talking about multiples and factors, we use one number to find the factor of that number. We use two number to find the highest common factor, right? So if I have just one number, I can only find the factor or the prime factor. But if I have two or more numbers, I can find common multiple, least common multiple, common factor, highest common factor. Okay, so the requirement is that we should have two or more numbers always, right? When we are finding the LCM and HCF. A quick recap, what does multiple mean? Multiple are number that result from multiplying by an integer. For example, multiples of 4. We just have to write the table of 4 by multiplying it with 1, 2, 3 and so on. Right? So 4, 8, 12, 16, 20 are the multiples of 4. Right? Then factors are the numbers that can be multiplied to get another number. For example, factors of 6 are 1, 2, 3 and 6. Right? So if you look at 6, and if we use the conventional approach, we'll try to find the factor pair. So we start with 1. So 1 times 6 is 6. Then we'll move on to 2. So 2 times 3 is 6. And then we'll check with 3. So 3 times 2 is 6. Again, we see that 2 times 3 and 3 times 2 is the same thing. So we'll stop finding further factors. So 1, 2, 3 and 6 are the factors of 6. And if we just want to find the prime factors of 6, we then use the factor tree method. So we have 6 here. We'll first start with the least prime number, that is 2. Right? And then we see if 6 is divisible by 2 or not. So it is divisible. So we'll write 2 3s are 6. Right? So one side we have 2, the other side we have 3. So both of these are prime factors. So we do not extend this any further. Right? So 6, we can write this as 2 multiplied by 3. And the prime factors of 6 are 2, 3. Right? So these are all the factors of 6 and these are the prime factors of 6. Okay. Let us now see what lowest common multiple mean. So to understand lowest common multiple, as I mentioned, the prerequisite is that we should have two numbers at least. Right? So the two numbers, we have taken 6 and 8 as an example. So first of all, we'll see how we can use our understanding to expand and study LCM. Right? So if I have 6, I know what multiples of 6 mean. Multiples of 6 means just a table of 6. So 6, 12, 18, 24, 30, 36, 42, 48. Right, so these are the multiples of 6. Then I have the other number 8. If I have to write the multiples of 8, it will be the table of 8. So 8, 16, 24, 32, 40, 48, 56, 64. So basically I'm reading the table of 8. Right. Now this is all about multiples. Now I have to find if these two numbers have anything in common or any multiple in common. Does 6 and 8 have any multiple in common? So that means common multiple, right? So do they have anything in common? So we'll just look at their multiples and see if there's something in common. So 6 is not there. 12, it is not there. 18 is not there. 24, it is common. So 24 is one common multiple of 8 and 6. Why? Because it comes in the table of 6 as well. It comes in the table of 8 as well. Right. Then we move further. So 30 is not there. 36 is not there. 42 is not there. And 48 is there. Right. Similarly, we have to go on and on. Right. So there will be another multiple called 72. So say if 72 comes in the table of 6, 72 comes in the table of 8 as well. Right. So if I have to write the common multiples of 6 and 8, they are 24, 48, 72, and so on. So it will go on, right? Because they'll have a lot of common multiples. Now, we understood what common multiples means. Common multiples mean the multiple that is common to both the numbers. Now, among these common multiples, what is the least multiple that we have? Or what is the least value that we have among this common multiple? It is 24, right? So, which means that the LCM of 6 and 8 is 24, right? So, what did we do? We first wrote the multiple, which is n. Then we found the common multiple of both the numbers. Then from the common multiple, we selected the one that is the least, which essentially means we have computed the LCM of those two numbers. So if I have given two numbers 6 and 8, their LCM is 24. Back to definition, the LCM of two numbers can be found out by listing out multiples of both numbers and identifying the smallest common multiple. So we listed out the multiples of both numbers and then identified the smallest common multiple, right? And if you notice, all the subsequent multiples or all the subsequent common multiples will be a multiple of the LCM. What do I mean by saying that? So if I have found the LCM of both the numbers, so the subsequent common multiples, so the second common multiple was 48, right? So the LCM is 24. Then the second common multiple would be 24 times 2. The third common multiple would be 24 times 3. The fourth common multiple will be 24 times 4 and so on. So if I find the LCM, there is no need to find any further common multiple because they will be the multiples of LCM itself. So this is the power of LCM. This is why we use LCM, right? Because this is the smallest common multiple and all the common multiples, all the further common multiples will be a multiple of 24 or the LCM. Okay, so once you know the LCM, and if you're asked to find 10 common multiples, you can just multiply or write the table of the LCM and find 10 common multiples. No need to list out everything. Okay, so your goal should be to find the first common factor. If we try to find all the common factors, so it will take us a lot of time. So our goal should be to stop here itself, right? No need to write any further number because we know that once we have computed the LCM, the second common factor will be 24 times 2. The third common factor will be 24 times 3 and so on. Okay. Similarly, we have highest common factor. So just like multiples, it applies the same concept. I have two numbers, 12 and 28. Right. So let us find the factors of 12 first. Okay. So the factors of 12, if I have to write the factors for 12, we'll use the conventional approach for now. So what do we need to do? We need to build factor pairs. So start from 1. If I multiply 1 with 12, I get 12. Then we move on to 2. So 2 times 6 is 12. Then we have 3. 3 times 4 is 12. Then we have 4. 4 times 3 is 12. But we'll not use this and we'll stop. Why? Because 3 times 4 and 4 times 3 means the same thing. So we'll not find any further factors. So the factors will be 1, 2, 3, 4, 6, 12, which is what we have written here. Similarly, the factors of 28, if you use the same approach, right? So 28, again we start from 1. 1 times 28 is 28. Then 2. 2 times 24 is 28. 2 times 14. Then we have 3. 28 is not divisible by 3. Then we have 4. 4 times 7 is 28. Then we have 5. 28 is not divisible by 5. 28 is not divisible by 6. Then 7 times 4 is 28. Again, we'll not use this because we have repeated the same thing. So the factors will be 1, 2, 4, 7, 14, 28. What we have written here. Now, what are the common factors? The common factors are 1, right? The common factors are 2. The common factors are 4. Right? So we calculated the factors of both the numbers. We have now also calculated the common factors. So the common factors of 12 and 28 are 1, 2, and 4. Right? Now we find the highest common factor. So among the common factors, which is the highest? It is 4. Right? So the highest common factor would be 4. Right? So, I mean, what was the advantage of using LCM? You just need to find the LCM, no, and you'll be able to find all the common multiples by just multiplying that by 1, 2, 3, 4, and so on. What is the benefit of finding the HCF? When you find the HCF, there is no need to find any other common factors. Using the HCF itself, you can find all the other common factors. How? So just find the factor of 4. Right? So the factor of 4 will again use the conventional approach. So 1 times 4 is 4. 2 times 2 is 4. And 4 times 1. 4 times 1 will not use because we have repeated. So factors of 4 are 1, 2, and 4. And you can see that the same common factors are for 12 and 28. Right? So once you find the common factor, highest common factor, no need to find all other common factors because all other common factors will be a factor of this. Right? And once you find the LCM, no need to find other multiples because all other multiples would be a multiple of LCM. Okay, this is very important concept. So LCM, I mean, this is the lowest common multiple. So since it is the lowest common multiple, all other common multiples will be a multiple of this LCM. Right? So LCM times 1, LCM times 2, LCM times 3, LCM times 4, and so on. HCF is the highest common factor. So all common factors will be a factor of that HCF. Right? Okay. Although you'll not get questions on this, but this understanding will help you when you go to higher classes. Okay. Now we'll see some examples and then understand it in more detail. Right. So first of all, we'll try finding LCM. First number we have is 8 and 12. We have to find the LCM of 8 and 12. So again, we will use which approach? It is known as the listing method. Right. So 8, I list out the multiples because we have to find LCM. So it is 8, 16, 24, 32, 40, and so on. Right? 12, it is 12, 24, 36. We can write just one more, 48. Right? 36, 48, 60, and so on. right? Now, if you look at the common multiples, is 8 present here? No. 16 present here? No. 24 is present. So 24 is one of the common multiples. 48 is another common multiple. But which one is the least? 24. 24 is the first factor, common factor that we found. This is the smallest. So LCM of 8 and 12 is 24. Now you can see, if you are asked to find 10 common multiples of 8 and 12, first of all, what you do, you found the LCM. Then the first common multiple is 24. The second common multiple will be 24 times 2. The third common multiple will be 24 times 3. Fourth will be 24 times 4, and so on. Right? Then we have to find the LCM of 9 and 15. Again, we'll use the listing method. So 9, the common multiples are 9, 18, 27, 36, 45, 54, 63, 72, 81, and 90. So we'll just stop here. For 15, we'll have 15, 30, 45, 60, 75, and so on. Right? So now, always better to write the smaller number first. Okay, then we'll search if we have this number present here or not. 9, not present. 18, not present. 36, not present. Right? See, you may have a question that, can't I find 36? So I have not listed out all the multiples. Can't I find 36 here? The answer is no. Why? Because the multiples are always arranged in ascending order, right? So if you are not able to find 36 here, all the numbers here will be larger than 36. So there's no chance that we'll be able to find 36 here, right? Then 45. 45 is here and here. And this is the smallest number or smallest common multiple that we found. No need to find any further common multiple. We just have to stop at the first common multiple. So LCM is 45. Using LCM, you can say that the second common multiple would be 45 times 2, which is 90. Right? So this is where LCM becomes helpful. Then we have 12 and 21. If I have to write 12, so the multiples would be 12, then 24. Right? Let me just erase this. So it will be 12, then 24, then 36, then 48, then 60, then 72, then 84, and so on. Then 21. It will be 21, then we'll have 42, then we'll have 63, right? Then we have 84. So we have to multiply this, right? And then we'll have 105, and so on. Now we'll just check. 12 not present, 24 is not present, 36 not present, 48 not present, 60 is not present, 72 is also not present, 84 is present. Right? So 84 is present. So 84 is the smallest common factor that we found, common multiple that we found. So LCM of these two numbers would be 84. And you can find other common multiples using LCM. Now see, in the subsequent session, we'll see this one, this particular example. All the previous examples we are able to find it quickly, but for examples like this and more larger numbers, right, it would be slightly difficult to find the LCM using listing method, or it will be very tedious. So we'll see another method that we can use to find the LCM, right? So that is known as the prime factorization. So that is why we studied the factor tree. Okay, before that, we'll see this example to find the HCF. Right, so we have the numbers as 16 as and 34. Right, so 16, we'll use the listing or the conventional method to find the factor first, and to find HCF we'll use listing method. So 16, we'll first find the factor pairs. So the factor pair is 1 into 16. Right, then we have 2 times 8, then 3 times 4, Sorry, 3 times 3, it is not divisible. 4 times 4 will have. 4 times 4. 5 not divisible, 6 not divisible, 7 not divisible, 8 it is divisible, but we have written the same thing again here. Right, so only factors are 1, 2, 4, 8, 16. So 1, 2, 4, 8, 16. Right, then we'll write for 34. 34, if we use the uh, factor pair, so we'll get 34. 1 times 34, 2 times 17. That's it. Because 17 is a prime number. So that means it is not possible to decompose this any further. Right? So 1, 2, 17 and 34. No other factors of 34. Right? Now if you look at the common factors are 1. So 1 will always be a common factor. Then we'll have 2. So 2 is a common factor of 16 and 34. So 1 and 2 are the common factors, out of which 2 is the highest common factor. Right? So common factors are 1, 2. Highest common factor is, which is highest among 1 and 2? 2. So 2 is the HCF of 16 and 34. Similarly, we'll look for 36 and 60. 36 again, if we find the factors, right, using factor pairs. So 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 not divisible, 6 times 6, right? Then 7 not divisible, 8 not divisible, 9, 4s are 36, but we have written it already. So we'll stop. Right? So the factors for 36 would be 1, 2, 3, 4, 6, 9, 12, 18, 36. Right? What about 60? 60 will write 1 times 60, 2 times 30, 3 times 20, right? 4 times 15. So it has a lot of factors. 5 times 12, 6 times 10, 7 not divisible, 8 also not divisible, 9 not divisible, 10 times 6, which is the same thing that we wrote here. So we'll stop. So 60. 1, 2, 3, 4, 5, right? Then 6, then 10, then 12, then 15, then 20, then 30, and then 60. Now you can see there are a lot of common factors. 1, 2, 3, 4, 5. 5 is not there. So 1, 2, 3, 4, 6. And then 12. We'll just highlight this. So 1 is a common factor, 2 is a common factor, 3 is a common factor, 4 is a common factor, 6 is a common factor, 9 is not a common factor, 12 is a common factor, 18 is not a common factor, 36 is not a common factor. So out of these common factors, which is the highest? It is 12. So HCF is 12. Right? Then we have 56 and 98. So 56, what are the factors of 56? 1 times 56, 2 times 28, 3 not divisible, 4 times 14, 5 it is not divisible, 6 not divisible, 7, 8s are 56, so 7 times 8, and then 8 times 7. So we have repeated the same thing, so we'll stop. So 56 it would be 1, 2, 4, 7, 8, 14, 28, 56. Right? For 98, we'll have 1 times 98, 2 times 49, 3 it is not divisible, 4 it is not divisible, right? 5 not divisible, 6 not divisible, 7, yeah, it is divisible. So 7 times, if you just divide 98 with 7, you'll get 14, right? 8 not divisible, 9 not divisible, 10 also not divisible. So you'll directly come to 14 again. So 14 times 7 you'll get, right? So if you have to write the factors of 98, so it will be 1, 2, 7, 14, 49, 98. Now if you look at the common multiples are 1, 2, 4 is not common. Then you'll have 7, 8 is not common. Then you'll have 14. Then 28 is not common and 56 is not common, right? So out of these common factors among 56 and 98, which is the highest? It is 14. So HCF is 14, right? If you look specifically at the last two examples, it was relatively difficult to find the HCF and LCM, right? Using the listing method that we have discussed so far. So in the next class, what we'll do, we'll look at a more simplistic approach using the factor tree that will help us in finding the LCM and HCF of both numbers. Okay.